Hi, I'm Darrell Bartholomew with Minnesota West Community and Technical College, and we're here today to talk about grain elevator firefighting. Some of the topics that we're going to discuss real briefly today are these. Incident command system. We want to make sure that the local fire departments, whoever the officers are in charge of a particular fire, know about the incident command system and how important it's going to be to involve that particular system in organizing their firefighting equipment, the local firefighters, EMTs, whoever might again be responding to this particular type of fire. We'll talk about some safety issues with regards to this type of structure fire, from the buildings themselves to maybe the firefighters themselves, and some issues that they need to be aware of when dealing with a grain elevator fire. Size up factors, several factors involving information about the incident, what resources are going to be needed for this particular type of fire, some guidelines for fire officers to take back with them regarding some of the things that they're going to need to discover upon arrival, and then size up the situation, determine what's going to be needed to deal with this size of fire. The other issues that we're going to talk about are the exposure issues. Usually the grain elevator situations, large buildings, maybe multiple buildings. What are the exposures around this particular structure? Is it a residential nearby? Is it more chemicals in the area next to the elevator? Propane tanks, anhydrous tanks, grain bins. We're going to talk a little bit about exposures and that priority during this particular type of fire. Water supply, big issue, possibly a big problem. Typically, a smaller town water supply system will be depleted very quickly if they totally rely on the local distribution system to supply the water for this particular fire. And again, depending on the size of the fire it is, obviously the more water that's going to be needed. So we'll talk a little bit about water supply as we get into the program. Then lastly, we'll talk about, is there any possibility for some environmental damage as maybe water is applied to a particular fire? What type of issues might be harming the environment? Again, involving maybe chemicals at the site, at the particular elevator. We'll talk a little bit about that at the end of the program. So we're going to discuss these particular items today in this particular order. And then we'll, maybe if we have time, we'll look at some other videos with regards to grain elevator firefighting. So, the incident command system. Been around a long time, since the 1970s. I think most of the fire departments are pretty well aware of the incident command system, and again, how important this is going to be to organize the firefighting effort in the event that this particular type of fire does happen in your community. Some of the key issues with the incident command system with this particular large event, we want to make sure that the officers are aware of that typical grain elevator fire, if one does happen, usually the local fire department is going to need some help with this. The call for mutual aid departments coming in, other maybe law enforcement, emergency medical services coming in, depending on the situation regarding this particular fire. But again, typically the hometown or the host fire department for a particular fire like this is going to need some outside help coming in to assist them. So we're going to take a look at some of the main functions of the incident command system that are typically used, typically going to be necessary for other units coming in to help out with this particular type of fire. Obviously, you're going to need an incident commander, a person or maybe several people in the event of a unified command system to organize, again, what resources are going to be necessary, who's going to be doing what, delegating different jobs to various people, again, using the incident command system. And again, typically in this type of fire, we're going to look at safety as being a big issue, one of the main issues that we want to kind of keep an eye on. And not, again, unlike other fires, but again, this is going to be one of the other officer positions that are going to have to be filled, again, following the incident command system, the safety officer. And it might be necessary to have several of these safety officers around the site during a particular fire. Another position or function within the incident command system that will be necessary in order for the incident commander to more safely, more in an organized manner, organize the effort from the local firefighters, and that is we're going to utilize the operations section. This is a section within the incident command system that is going to be doing most of the work, whether it's firefighting, whether it's traffic control, whether it's helping or hurt people or injured people. The operations section is going to be necessary. Within the operations section, there will be a water supply group or a water supply officer necessary. Again, with this type of fire, the magnitude of the heat and the fire that needs to be controlled, again, water is going to be one of the main resources that needs to be brought into the community to help deal with this situation. Again, so water supply officer might be different levels of that particular position, but water supply is going to be a main concern in this particular fire. How do we get the water to the place that we need it? One other function might be the exposure group or the division. And again, depending on the situation, how many exposures do we have at this particular fire? It might be different from one grain elevator fire to the next, but exposures are going to be a particular priority that will have to be dealt with one way or the other. So those are the basic functions of the incident command system that I would hope the local fire departments would put into play, would delegate some different people to take over these particular functions and organize the effort in a more legal way as far as dealing with the situation. Again, getting the resources to the scene, whatever might be needed, and organizing the effort when the firefighting activity does begin. So there's a little bit on the incident command system itself and some of the key functions with regards to the incident command system being used in a particular event of a grain elevator fire. The command sequence, the next thing that we're going to talk about real briefly, is just more of a step-by-step process of dealing with this particular type of incident. And again, it's not a whole lot different from other type of fires or other type of emergencies, but here's the command sequence as it might play out once the fire department is paged out to this particular incident. Again, size up. One of the first things the fire officers are going to have to do to obviously determine what has happened, what's going on, what type of fire, what resources they're going to need. So there's some size up of the incident. Again, probably not a whole lot different than your if you will, the typical structure fire. Even though the grain elevator is going to be obviously a bigger structure. Again, size up of the incident. Okay, the identification of the problem. Okay, not only the fire, are there other problems that might be a part of that scene? Again, the chemical environment, propane tanks in the area and hydrous ammonia tanks in the area, other chemical storage. What are some other things besides the building being on fire that might have to be dealt with? The next step is to determine, based on the size up and identifying the problems and maybe some additional issues that might have to be dealt with at that particular moment, we're going to ask that the fire departments come up with strategies and tactics to deal with those particular problems. Again, strategies and tactics, two different terms that we use a lot in firefighting. Strategy is more like an overall goal. Some of the tactical objectives would be the individual tasks to meet the particular strategy. So there's those two terms that are used quite often in this type of emergency situation. Developing an action plan. Once, again, size up's been done, we kind of have an idea what type of situation we have. We might have an idea that we are going to need some additional help in this. We're going to develop some strategies and tactics. Maybe it's exposure protection right off the bat. Maybe there's rescue that might be needed if in case it is a result, the fire is the result of maybe a grain explosion. Are there employees in the elevator that need help? So that's going to bring a different approach to the response to this particular incident. So again, develop an action plan. All the different things that are going to have to be done to bring this fire, this incident, to a safe conclusion. Once the action plan is discussed, again, we're going to look at the resources that we have. Do we have enough resources to accomplish all the items and the issues with regards to the action plan, or do we need to prioritize a little bit here with regards to, maybe at the beginning of this, lack of resources? So we're going to implement what we can with what we have as far as resources. Then the last step in this, and it's an ongoing process of evaluation. We have an incident. We've started in firefighting and in traffic control and all those other avenues of response that we're going to have to do at this particular type of fire. But again, once we start dealing with the situation, sometime later, and probably not too long after the pagers go off, where someone's going to have to evaluate what we've done. Is it doing any good? Are we making progress on the fire? Is the fire getting smaller? Or is it spreading? Or are there more exposures that are going to be needed to be dealt with? So again, the evaluation process, once actions have been taken, have we done what we thought we were going to do as far as strategies and tactics are concerned, or do we have to change game plans or, again, add to the action plan? So some of those things with regards to the command sequence, maybe not in that particular order, but typically that's what it's designed to do, is to kind of allow us to flow through the incident, gathering information and dealing with the particular incident. So the command sequence going along with the incident command system. I'm going to move into some safety issues. These are, typical safety issues, and some of the pictures that you're going to see on the slide program or in the PowerPoint program here today basically are the result of training drills that have been done with burning a grain elevator to the ground in various communities. So you'll see several different pictures from actual elevator burns that we've done for training purposes in the last recent years. Some of the safety issues that we typically see with this type of incident, okay? And here's just some of them. It might not be the total list of safety issues, but here's some things that we've looked at, we've identified in previous situations with this type of incident, again, involving a grain elevator. Possible dust explosion. If it hasn't happened already, could it happen during the response to the incident? Be aware of the dust explosion possibility. These are all awareness points. Some of these things need to be addressed, obviously, but again, keep in mind that any one of these things could be part of that particular fire. Potential building collapse. Bigger structures typically, when you get into the mills and when you get into the higher storage elevators, again, tall buildings typically, you'll see the potential for maybe building collapse. So those things have to be looked at. Part of the job of the safety officers to keep the scene safe, keep people safe that are maybe around those particular type of structures. Metal falling from the elevator itself. Once the elevator is burning to a certain point, again, some of the siding, the metal siding will start to let loose because the nails will or the screws will let loose, and now the metal will be flying towards the ground in not any particular fashion, but just some of the issues that we've seen with regards to these types of fires. Power lines. Are there any power lines feeding either the elevator itself or that site, or are the power lines coming into town to supply power to the community? We see the power lines in a lot of different places. Sometimes because of the magnitude of the electricity that the elevator will have to use, obviously we see some pretty good size voltage anyway, power lines coming near the grain elevator itself. So are those a hazard in the event of a fire next to them? Other structures or components of the elevator process. And again, not in any particular order, but are there grain handling legs that transfer grain from one part of the elevator to the next? And usually they're elevated, usually they're suspended. When they start to fall, we don't know where they're going to go. So again, some of those issues there. Conveyors, silos, grain bins, other structures that might be part of the safety walkthrough that will have to be identified as potential safety issues. So again, safety issues, safety concerns, We want to have everybody that's coming to this particular incident to go home safe when it is done. So some of the things that the safety officers are going to have to keep an eye on. Again, not a whole list possibly, but here are some safety issues. Here's just a picture of one of the burns that we did some time ago. But again, as you can see, as the elevator is being destroyed by the fire, obviously the metal siding has let loose and it's heading towards the ground. Again, no guarantee where it's actually going to end up. And with the air movement around these particular bigger structures, once they're on fire to this magnitude, again, typically the steel will go all different directions, and we want to keep people out of its path. So again, a good collapse zone around the structure to begin with as far as the safety issue is concerned. So one of the things with regards to this type of structure during this particular stage of the fire. Well involved, the building's coming down here the way it looks. Again, some of the concerns that we have. So those are some of the safety issues. I'm going to talk a little bit now about the size-up factors. Here's a couple of factors that, again, the officers in charge will need to take a look at as we, size up the situation. What kind of a problem do we have with this particular type of structure? All right. Prior knowledge of the site. Are there, again, chemicals nearby? Where are the storage tanks? Where's electricity going to be cut off at? Where's the gas meters for propane or natural gas feeding the elevator? Some of the prior, maybe pre-planning information is going to come in real handy with regards to the initial size of this particular fire. Experience involving this type of fire, this magnitude of fire. How much experience does the local fire department have in mutual aid operations? Again, the need for more water coming into town. Just, again, prior experience with all of that. Evaluation of immediate facts. What do we know when we get there? What do we know when the pager goes off? Some of those particular issues we need to evaluate a little bit. Evaluation of potential change. Maybe it's weather. Maybe it's wind. What might affect, responding to this particular incident, again, once the firefighting effort is set forth during the incident. And again, consideration of available resources. Like I said before, your typical fire department, local fire department might be overwhelmed real quick with this type of fire. The need for mutual aid units, other fire departments, other emergency responders coming into the community to help out with this particular situation, absolutely, positively going to be needed. So again, how do we get those additional resources on the way to that particular location? So that's the other thing. We have an incident. What type of resources do we have at the beginning here? We might have to call in mutual aid fairly quickly because this type of fire, in most cases, is going to overwhelm a local fire department. The key size up questions. Here are some points to consider possibly during the size up process. Again, one question right off the bat, if that information about a grain elevator on fire is not broadcast on the pagers, we'll eventually find out what we have upon arrival, okay? What have we got? We got a huge building on fire possibly, okay? What's burning? Maybe it's the elevator, maybe it's an outside structure, maybe it's the feed storage area, but what do we got? Actually, that's part of the fire activity right now. Where is it going to go? How much can it consume, the fire? Again, additional exposures, additional buildings, what's all part of this particular site at that particular moment, okay? Again, other exposures, who's in its way, what's in its way? Again, propane tanks, anhydrous tanks, feed storage, grain bins, what else is there that might become part of the situation? What are we going to do? What are we going to try to do here? Obviously put out the fire, keep everybody safe, some of the issues that we need to consider. And again, the water supply will be typically one of the major and sometimes problems with this particular incident. Where's the water coming from? As I mentioned before, typical community water distribution system is going to be, again, overwhelmed with the amount of water that's going to be needed to deal with this size of a structure as it's on fire. So again, some real quick, size up factors. What can we do with what we've got? Where are we going to get the water from in this type of fire situation? So again, some key size-up questions that might be appropriate for this type of situation. The next couple of slides are going to be involving what we call the basic divisions of firefighting or fire strategy. Okay? And basically it's an acronym based on the different functions or processes that are going to have to be looked at. Again, maybe not just during a grain elevator fire, but again, a typical fire response. Rescue is always going to be number one. Remember, people come before property or building or the environment. If there's any rescue that needs to be done, that's going to be the first priority. People come first. Next, we'll look at exposure protection. Like I said, what else is around that particular elevator? Is it a residential area of town? Or is there parking lots that have nothing next door? What are the exposure potential problems here? Power lines and other grain bands, other structures. Again, residential areas. So again, we're going to have to take a look at that. The next one is confinement. Again, confinement obviously is we're going to try to stop the fire. We're going to confine it from consuming any other structures, any other buildings, so on and so forth. So we're going to confine the fire, try to confine the fire to the size that it is upon arrival. Extinguishment, obviously, that's the game plan. We need to put the fire out. Do we have the resources to do that, however? Okay, so what are we going to need to not only confine the fire, but let's put the fire out? Extinguishment is the next thing we're going to look at. Overhaul, basically, we want to make sure that the fire is out. We're going to do our overhaul efforts to make sure all the embers are taken care of, all the spot fires are taken care of, the fire is out. Then the other two off to the side, the ventilation category and then the salvage category. Again, typically, they're going to have to be put into the process as needed. So some ventilation efforts as far as ventilating the building. We might have to get the smoke and the heat out of the particular structure, so some sort of ventilation if it hasn't been done naturally through windows and doors and alleyways and so on and so forth as we look at a grain elevator type structure. The salvage of that particular building, limiting the damage from the smoke and the heat, the fire, and maybe even the water. So what are we going to do possibly to reduce the damage that's done by the fire and or the firefighting efforts? So maybe salvage and ventilation are going to have to be brought into the picture along with the other 5 items that we just mentioned. So again, size up on the scene. The fire officer is going to take a look at the situation. What type of situation do they have? What type of fire? How much is involved with the fire? Again, this is going to be a continuous process, this idea of size up. It's not going to be just the first 5 minutes and then we're going to forget it. It's going to be a constant size up of the situation. As we begin firefighting, we're going to take a look at, again, what are we doing? Is it making any difference? Is the fire getting smaller? Or is it getting bigger? Is it spreading to other structures? It's going to be a constant process of the size up. Some departments will have a tactical worksheet. Now, I know this is fairly hard to see back there, but again, some way, some process that the fire officer can help. This tactical sheet will help the fire officer determine who's doing what equipment is where on that particular site. Again, all the different strategies, all the different tactics from water supply to ventilation to exposure protection, medical assistance for maybe possibly injured workers, so on and so forth. It's all there. And who's doing the work with regards to dealing with all those particular elements of a particular situation. So a tactical worksheet, deployment of people, deployment of equipment, knowing who's doing what where. It might also include a sketch of the scene, streets, alleyways, buildings, of course, exposure buildings next door, so on and so forth, a bigger picture of the incident site. So a tactical worksheet sometimes comes in real handy in trying to deal with this magnitude of a situation. Number 2, again, rescue. Okay? After size up, rescues the first thing that we're going to take a look at. Are there any people in need of being rescued? Might be firefighters, might be other responders on the scene. It might be civilians. It might be, again, workers at the elevator. Not just for the emergency responders, but there might be employees that might need help at the scene. So again, people come first. Exposure protection, again, depending on the building in question, the building that's on fire, it might be the office area that might be exposure, or it might be the Quonset building next door, or it might be the residential houses next door across the street from the elevator, if it's that type of a scene. So there's a lot of different possibilities for exposures. Again, one of the things that we're going to have to look at and maybe even use as a priority with regards to this type of fire. So again, we're looking at structures and buildings that are closest to the fire, and then spread out from there as we develop exposure protection plans. The exposure protections, again, do we have the water flow? Do we have the water supply to protect all of them? Or do we need to prioritize what exposures should be protected first because of maybe the limited resources at that particular time? The radiant heat also is a problem with this type of structure. Large fire, a lot of radiant heat. That's basically how, in most cases, how fires spread. Radiant heat. Warming or heating up other structures, we need to take a look at that. And again, you'd be surprised if you haven't determined this already in previous incidents how far the radiant heat will travel. You might think a building that's several hundred feet away might be safe from the radiant heat, but again, you might be surprised. Some other factors involved with that obviously would be, the material of the building in question, the exposure building, what type of siding does it have on it, wind direction, wind speed, all those kinds of things might have a factor to look at with regards to exposures. So again, the radiant heat. As I mentioned before, what else might be on site? That might be an exposure. Propane tanks, got to keep them cool if they are nearby, might be the biggest priority. Chemical containers as well, grain storage structures, grain bands, grain silos, whatever they might be. They might be a part of the exposure size up. And ember fallout as well. Maybe not a particular building here when we look at it as an exposure problem, but now we have embers flying several hundred feet to maybe even, maybe not miles, but quarters of a mile, half a mile away from the structure. Ember fallout. The incident commander is probably one of the functions that they're going to have to man is maybe a grass rig or a truck or something like that with a couple of crew members to look and see where the fallout is. Are there hot embers falling on roofs of other buildings and so on and so forth. So ember fallout, maybe a bigger far-reaching exposure versus the structures that are a little bit more closer to the actual fire building. So exposure protection concerns several of those. And here's just an example, this slide or this picture of an example of one of our training burns. But again, we see buildings nearby, we see power lines nearby, just some exposures to this particular fire here in this picture here. So again, we got to look at the big picture. At the beginning again, during the size up, the chief officer or whoever's in charge initially of this incident will have to look and do a 360 around the building, see what else is around that particular structure. Again, we're looking only at one side or two sides here of this structure in this picture, but again, we have some major potential exposure problems that we're going to have to take care of or at least address during that particular fire. So again, some exposure concerns. Here in this picture too, we see other warehouses or other storage facilities nearby the mill or the grain elevator. Okay? Some other buildings that we're going to have to protect. Exposures. We have to have enough water to keep those additional buildings cool so they don't become part of the fire itself. Exposure protection. So again, large structures, usually other structures nearby, storage tanks. We have to, look at the big picture. Grain bins. Here's another picture from another training burn. Again, grain bins, several of them, near the structure that is burning. Do we have enough water to keep those particular facilities or storage containers cool so they don't become part of the problem? They're not damaged. Maybe there's corn or other grain inside these storage facilities. Is that going to be harmed as a way of the fire heating up the containers or the grain bins? So just a lot of exposure concerns out there. Again, usually means we're going to need more water or additional water supply brought in to deal with the actual exposures. And again, it might be to the point where the structure itself is not going to be saved. We need to switch priorities possibly and look at the exposures as saving them. So some exposures. Another exposure that we have to keep an eye on or remember, and that is the railroad tracks. Again, during this particular training burn, one of the exposures that we were cognizant of, we had to protect the rails. Let's not get the rails too hot. Again, might not be the first priority. Probably other buildings are going to be higher on the priority list, but again, this might be another exposure that's going to have to be protected. Again, cooling the rails down so they don't become part of the problem. Again, not probably one of the higher priorities as far as exposures are concerned, but something to think about. Depends on the situation. So those are some of the exposure protection issues, some concerns, some typical exposures we're going to find and run into with this type of fire, again, being a bigger structure. Confinement. What are we going to do to prevent this fire from spreading to other parts of the structure itself, maybe the office building next door, so on and so forth? How are we going to confine this? Are we going to have to set up additional hose lines and fire streams and those kinds of issues to prevent fire from spreading to other parts of the structure? Extinguishment itself, getting to the point where now we're able to put this fire out. Again, what are the resources we're going to need? Water supply, so on and so forth. What are we going to need to not only knock it down, but control the fire, put it out? Extinguishment, we're going to put the fire out. Some water supply requirements when we're talking about fire extinguishment. And on the screen right now, there's two different formulas that are typically used in the calculation of how much water are we in need of based on the structure that we have on fire. Two different formulas. One that's been around a long, long time, and that's the Iowa formula. Basically, the fire officer, upon arrival, can take a look at the size of the structure. We're not talking about taking a tape measure out or doing any of that stuff, but an estimate of how much, basically, cubic feet of building do we have. Taking the Iowa formula, we're going to take the length and the width and the height, divide it by 100. That will result in the gallons per minute flow that we're going to need to control that particular fire. So maybe a real quick way for the fire officer to estimate the size of the building, how much cubic feet of building do they have, divided by 100. We're going to need basically that many gallons per minute to control or to get the fire extinguished. So that's one formula. The second formula that you see on the screen is the National Fire Academy formula. A little bit different, kind of the same concept though. They look at the length times the width divided by 3. Then how much percent of the building is involved. So you take the square footage and then again look at the percent of the building that's on fire. So it might be a larger amount of gallons per minute we need, or if the building's only half involved, we can maybe get by with less water. But again, those are just a couple of formulas that again first arriving officer can take a look at and estimate the size of the building, calculate real quickly, real simple, how many gallons per minute are we going to need to deal with this particular structure. If there's our exposures nearby, well, that's just going to add to that particular water supply requirement. So a total picture of the water supply, not only the building that's on fire, but what other exposures do we have to take care of as well. We're going to need water for those in addition to the actual building. So water supply requirements. What water supplies are available? Okay. As I mentioned a couple of times already, typically with this size of structure, the local community's water distribution system will be drained, will be depleted fairly quickly. Okay, we're going to need several thousand gallons of water in a particular situation. So we're looking for other sources of water, typically rural areas. Are there lakes? Are there rivers? Are there dry hydrants? Where are we going to get this additional water that the city system cannot supply for this particular fire? So again, some water supply requirements, again, based on the formula calculations that was done prior. And again, we're looking at, here's another picture of a particular structure using the Iowa formula here, the length times the width times height divided by 100. It's measured. Again, don't have to be quite as exact in this calculation, but again, right around 800 gallons a minute. That's what this building is going to require for water supply. Okay, not only getting the water at the fire, but how are we going to distribute the water to get the water in the right location? How many nozzles? Are we going to need aerials? Are we going to need ground monitors? What are we going to need to get that many gallons per minute delivered to the fire by way of different appliances and so forth? So not only getting the water to the site, but how are we going to apply it to the building to, again, confine and or extinguish this particular fire. So again, fire flow required, gallons per minute. Some other water supply requirements. Based on the situation, do we need more pumpers in town? How many more pumping stations do we need to basically surround this particular structure and protect the exposures around this particular building? Are there any aerial apparatus in the area that you might be able to get into town to help out through mutual aid agreements and so on and so forth? Again, aerial apparatus, very, very useful so we can get the water applied from a different direction besides just from the ground level. How many fill stations? If you're going to use hydrants in town, how many hydrants are we going to use? If you're going to use rural water sources, again, dry hydrants, lakes, rivers, drainage ditch, how many filling stations? We're going to have apparatus and personnel out at those locations too to fill the tenders so they can bring water into the community or to the fire scene. So again, all part of the process of size up. Where are we going to get the water from? Drop tanks at that particular location. Okay, we might have different firefighting stations here. We're going to need more pumping apparatus. We're going to need, obviously, drop tanks, in addition to the hydrant hookups that might be done in this particular type of fire. So again, some other water supply requirements. If you're going to bring in water from the outside of town, rural environment, are we going to need a water shuttle process? Some of the issues with regards to the typical water shuttle process, all right? How many tenders are you going to need? Well, you can go back to that main calculation. There's the gallons per minute we should have, might not have, but that's what the figures show. We might need that much water. How many tenders are we going to need to get that amount of water to the site? What travel routes are these tenders, these motor vehicles, going to take to get from town or from the site of the fire out to the water supply and then back to the fire? What travel routes are they going to involve? Are they going to involve gravel roads? Are they going to involve paved roads? Again, some safety issues, again, when we put these vehicles on the road in an emergency situation. One of the main concerns we have with the tenders, and that is they're going to be way more effective if we keep the tenders moving. If the tenders are stopped, they're not moving out to get water or delivering water back, we're going to really reduce our gallons per minute flow at the fire. So again, some of the things there, we need to keep the tenders moving. Can water augers assist in getting the water loaded out at the fill sites, wherever this water supply might be located? Again, a creek, a river, a lake, so on and so forth. Where are we getting the water from? You might have to have a device or equipment out there that can more quickly, more effectively, more efficiently load the tenders so they can, again, haul the water back to the fire site. Again, who has them? And again, how are they going to get to that particular location? Usually they're on wheels. Someone's going to have to, bring them to the particular site. Here's a picture regarding a area apparatus in use. Again, If they're in the area, get them on the way, get them to the scene. Aerial apparatus, a large volume of water can be applied now from a higher level, not just from the ground. It might be a real big benefit in confining and or extinguishing the fire if we can get water not only going from the ground up to the fire, but obviously the water coming down onto the fire. Might solve a big problem for confinement and will help with the extinguishing process. So again, aerial apparatus, are there any around that can be mutual aid called into that particular fire? Tankers, water shuttles, tenders, drop tanks. How are we going to set this up? This is going to take some time to set this up in a real situation. Training drills such as you see here depicted, this is all set up ahead of time before the building is started on fire. Well, during a real situation, we're not going to have that time. We're going to have to set this up as these units arrive in town. And again, there has to be a plan where this is going to be located, how it's going to be designed, how the tenders are going to be backing in and driving away from the drop tanks here. How is this all going to be set up and where? With regards to now your water supply being brought into the site. So you'll see a couple other things here on this picture besides the pumpers off to the left and the tenders off to the right, obviously the drop tanks in between. You see hose lines and drafting lines between the tanks, moving water from one drop tank to the other. Might be necessary to set up some of that equipment as well. We need to get the water to the pumpers here who are drafting out of those particular drop tanks. So a lot of setup time, a lot of organization to this particular fire site here as well. Another idea is take advantage of the pumping apparatus that you already have. Don't forget that the typical centrifugal pump in your pumper will pump a lot more water than one drop tank can supply. There's no problem with setting up dual drop tanks. This truck can draft out of both sides without a problem. So the more water we have, the more water we can get into the pump. Obviously, the more water we're going to be able to deliver to the fire. So you might increase the fire flow just by putting another drop tank on the other side of the pumper. So don't forget, the pumpers can draft from all different sides at the same time. Okay, so this might be another little trick that might be available to you. Rather than setting up multiple drop tanks and multiple drop tanks at the fire site, we can maybe increase the flow out of a particular pumper just by increasing the water flow as depicted here by setting up just another drop tank, getting more water to the fire. So don't forget that little idea as well. Here's a couple of pictures of water augers, some typical water augers, a couple of different designs here, but remember these have to be transported. Mutual aid calls probably have to go out. Don't forget those. If that's what you're going to think of using to deliver your water or to load the water out at the fill sites, if they're local, they might be worth bringing them in. And there's a couple of different designs here how the water comes into the auger. Basically, I think you understand, most of you I think understand that the tank or the tenders will drive underneath the auger to be filled in the way they go back to the fire. So different designs of the water augers, but are there any in the area that you can get a hold of to help deliver water to that particular fire? Again, another possible water supply resource here or source of water would be maybe a local river or lake. Maybe the local fire department, your local fire department, has a dry hydrant system already piped in, if you will, to this particular lake or river or whatever it might be. Know where these are at. Obviously, if this is in your particular jurisdiction, you know where it's at. Do other departments around your mutual aid area, do they know where these dry hydrants are located? And remember, you're going to be drafting from these particular dry hydrants. So you're going to have to set up, again, a drafting station. You'll basically connect the hard suction line right into this device and draft away. So again, where are they at? Are they, the approach to these particular dry hydrants, can you get fairly close to them, so on and so forth. But again, might be another resource to get water into town with. So again, dry hydrant locations. Identify them, work with them, practice with them. They're going to be a good resource, again, for some situations. The next slide here, this next little area here is a tanker flow rate. When we look at a particular, and we should change the term to tender, obviously, the tender flow rate, basically how much water will this tender deliver to the fire? Well, most of it's going to be concerning how much time is involved here. The time that we have to add up, and that will be determining how efficient, how many gallons a minute of water will this tender supply to the fire. Okay, so we're going to take a real quick look at just a real couple, quick calculations here. But again, you'd be surprised how your typical, or how much water your typical tender will be able to deliver to the fire. That's what we're looking at here. And again, we're looking at how much time does it take to load water onto the tender. How much time does it take to offload that water from the tender? How much time will the tender be spent on the road driving out to the water source, back to the fire? All in minutes. We take all those minutes, you divide that into the tender size. How many gallons? And again, we have a real quick example here, basically. We have a 2,000 gallon tender, and the travel time, or the miles to the water source, is 5 miles. So again, how much time does it take to load? How much time does it take to offload? How much time does it take to drive out to the water source and back? The minutes. Travel distance, we're going to say it's 10 miles round trip. Travel time, 2 minutes times 10 miles. Basically, you can't go 55, 60 miles an hour the whole trip. Obviously, we're going to average that a little bit. We're going to say that that 10-mile trip is going to take 20 minutes. And the handling time, offloading the water, loading the water, another 8 minutes. So we look at the bottom line. We have 2,000 gallons of water on this tender, and it's taken 28 minutes. You basically divide the gallons of the tender by the amount of time that is needed to get it loaded, unloaded, the travel time, so on and so forth. Again, you can round that off to 30, but you're looking at right around 70 gallons per minute. That's all that 2,000 gallon tender, based on the 5-mile run, will deliver to the fire. So you might think 2,000 gallons of water is quite a bit of water. Well, it is, but when we have to move that water 10 miles round trip, it really drives down, because of the time involved here, the actual gallons per minute that tender can deliver to the fire. So again, you look at, maybe our previous calculation, maybe we needed 800 gallons a minute of water. Well, we have one tanker, it's only going to supply less than 100. We at least need 8 more that size to do what we thought we needed to do with regards to the size up of the structure. Okay? So that's kind of how we have to look at that. Your typical tender, it sounds like it holds or delivers quite a bit of water, 2,000 gallons, 2,500 gallons, whatever your tanker might, or your tender might be. Again, it might not be that big. It might not deliver that much water, depending on the time involved with getting it filled, getting it offload, and driving it down the road from the fire site out to the water source, and again back to the fire site. So again, time is an issue here. All right. So again, mutual aid calls. Get those other tenders from other departments on the road coming to your particular location. We need more water. We need a way to get that water to the fire. So again, here's just an example of a tender flow rate. Mutual aid. One of the things that we want to make sure we do fairly quick here, and that is realize that if that grain elevator is on fire in your community, your fire department is probably not going to be able to handle it by yourself. You're going to have to get the call out. You're going to have mutual aid calls to the different departments around here. You need help with this thing. So don't delay that mutual aid call. You will need more water. You'll need more pumpers. You're going to need more tenders to get that water to the site. You're going to need mutual aid. Don't delay. Don't get to the fire and do some firefighting for 20 minutes, half hour, and then determine that, well, we need some help here. Do it now. Do it right away. Do it on the onset. Do it upon even before you arrive at the scene. Maybe it's an automatic mutual aid request. Maybe it's an automatic process that your county possibly has, where if we have this type of fire, it's an automatic page to the other departments. Get that equipment, get that personnel coming to your site as quickly as you can. Don't delay that. We see that all the time where the mutual aid call wasn't done soon enough. But we need it. We're going to need additional resources here, whether it's people, whether it's equipment, whether it's other water, transfer devices, so on and so forth. Let's get those mutual aid calls made early. So again, we can maybe do a little bit better job in not only firefighting, but exposure protection and all those kinds of things, because we now have maybe additional water coming in. So again, going back to the functions here. We've talked about, excuse me, we've talked about rescue. Might be necessary, might not, depends on the situation. What exposures do we have, right? Where are we going to get the water to take care of them? What are we going to do to confine the fire? What are we going to do to extinguish the fire? If we've accomplished the extinguishment, we've confined the fire maybe to a building, maybe we've confined it to not spreading to other structures, well, now we've got basically a handle on this particular fire. During the overhaul phase here, let's make sure that this thing doesn't start up later. We've got the fire completely out. We're not going to have to come back 4 hours from now and start the firefighting activity all over again. Let's do a good job and overhaul the first time so we don't have to come back and basically put the fire out again. So overhaul. It might be necessary to pull part of the building apart, to check for fire extension and those kinds of things. This type of structure, your typical grain elevator, again, you might need some heavier equipment. Backhoes, front-end loaders, those kinds of things. That might be necessary to deal with that particular phase of the incident. So the overhaul. We want to make sure that the fire's out. Again, some additional equipment you might need on site. Backhoe or excavators or whatever might be a local again. Might not obviously be part of the city operation. You might have to have a mutual aid call to the construction company to bring their equipment in. Okay? Might be local, might not be, but where are those resources located if they're not within your community? So another things to think about, where are these special resources, if you will? Where are they going to be available from? How are we going to get them to that particular site? Again, thinking about that whole process. Ventilation, as I said, might be necessary, might not be necessary. With this particular type of structure, a little bit different than a residential house. Ventilation might not be as important here as it might have been in another type of fire. And again, salvage, okay? Water damage, smoke damage, that's what we're trying to prevent here with regards to salvage. So those are the functions as we look at some of the functions that we're going to take a look at, have to take a look at when we arrive upon scene. The final part of the program today, we're going to just spend just a couple of seconds here on talking about potential environmental concerns. Again, depending on the site, depending on the elevator, does this particular site or business have chemicals on site versus just grain storage? Are there any environmental concerns as far as possible water runoff, those kinds of issues? This might be necessary to deal with. Again, depends on the site. You might have to try to do some containment of the water runoff as you're putting many gallons on this particular fire. Has it been involved with some chemicals that obviously were on site? But again, remember the priorities that we talked about earlier. People come first. We want to make sure that all the responders are safe. The people around this particular building are safe. We want to take care of people first. Then we're going to look at the property, trying to protect that, obviously confining the fire, those kinds of issues. And then lastly, we're going to take a look at the environmental concerns, if there are any that we have to deal with in that particular situation. So environmental concerns, we can't not look at those. We have to make part of that, environmental concern part of the process of dealing with a particular grain elevator fire. So something you might have to look at. The video segment that we're going to take a look at, just a real short video segment, again from one of our training burns that we did several years ago. Just a real quick viewpoint of how one of these actually looks when it's on fire. And during the video, you'll see, obviously, if it was a real situation, off to the left of the building that's on fire, it looks like to be feed storage. And what we'd probably do in a real situation is try to cut the fire off from the main fire building, and we don't want to allow the fire to spread to the feed storage, which is going to be on the left side of the building as you look at the video. We probably want to put some hose lines interior if it's safe to enter the building. We need to cut the fire off from spreading to the feed storage area. Just another problem as far as exposure protection, and more likely though confinement and extinguishment. The smaller we can confine the fire, probably the higher likelihood that we're going to be able to extinguish the fire. So again, the video is from one of our training burns that we have done in Ballatin, Minnesota several years ago. In summary today, grain elevator firefighting, what can I say? A lot of different types of things that will have to be looked at, different types of functions. This is different from your normal residential structure fire. You're going to need more help with this situation. You're going to need extra equipment. You're going to need extra personnel. It's because of the magnitude of this particular type of fire. You're going to need the mutual aid departments coming into your particular location, helping you out. Again, do not delay that call out to mutual aid. Priorities, just like any other situation or incident, we might have to prioritize what we can do at this particular moment because we don't have enough water yet to deal with this fire. Maybe we need to protect exposures. Maybe we need to confine it with the water that we have rather than trying to extinguish the fire. Again, priorities might have to be made, keeping in mind people come first. Safety of responders, we need to take a look at that. Watch that building collapse area. You know how high some of these structures are. We don't want to get people too close with hand lines or ground monitors, the actual firefighting activities. Keep them away. Watch that collapse zone of some of these taller structures. Strategies for exposure protection has to be looked at, as we mentioned before. The fire magnitude of the grain elevator might be, overtaxing what we have for resources. So again, strategies for exposure protection might be the first thing that we might want to try. Again, all depends on the situation. And lastly, when we look, and you've seen some pictures from other training burns that we've done with grain elevators, including the video you just saw, but again, practice this process of fighting a grain elevator fire. Mutual aid drills, water shuttle drills. Where are we going to get the water from outside of town? How are we going to get it into town? Practice with your mutual aid departments. I think that's a key to how successful your firefighting activities might be when we look at a particular incident. So bring all of your mutual aid departments together once in a while. Practice with some of the water shuttle and water movement activities. Again, you're going to need some help with this particular fire. That again concludes the presentation today. Again, I'm Darrell Bartholomew, Minnesota West Community and Technical College, and thanks for listening. And that concludes the program.